Okay, hello everybody. We are working in the homework lab now. And so we had left off talking about these types of problems where we're going to be solving exponential equations. And so there'll be a couple ways to do this. The first one highlights, I think, a common base problem. So we have 9 to the 2x minus 12 equals 65, 61. And the question is 65, 61 a base of 9? And so we'll need the calculator out. So 9 times 9 times 9 times, and we're looking for, okay, so it looks like it's 9 to the 4th power. There were 4 9s that made 65, 61, that's 12, equals 9 to the 4th, right? Now that the bases are equal, then that means that the powers are the same, and we are off to the races. 2x is equal to 16, x is equal to 8. Just put an 8 in here without the x equals. Number 2 looks similar. It looks like everything here is a power of 2. You have 8 to the x plus 5 equals 32 to the x minus 9. Both 8 and 32 are powers of 2. 8 to the 35, 32 to the x minus 9. We'll rewrite the 8, so we'll make this remark that these are powers of 2. All right, so that 8 is 2 to the 3rd raised to the x plus 5 equals 32 is 2 to the 5th raised to the x minus 9. And now we're in the business of multiplying these powers. You distribute the x plus 5, the 3 times the x plus 5, that's 3x plus 15 equals 2 to the 5x, and then 5 times 9 is 45. Make sure you distribute the 3 and the 5. I have 2 exponentials that are equal, the bases are equal, so that means that the powers are now equal, and you will solve for x appropriately. 60 equals 2x, x is 30. Number 3 is an exponential function, and the bases are not the same. There's going to be a procedure that I think we talked about a little bit on how to solve this. I'll solve it here. It's 13 to the x power is equal to 17. And when you see most of the problems here, no matter how bad it looks, this will be the way that we do it. Let's make sure that we're very clear about the directions. It looks like that they want natural logarithms or common logarithms to be used here. I prefer the natural log, being steeped in calculus. So the first step here is to take the natural log on both sides, or you can use the log on both sides, the common log. So the natural log of 13 to the x is equal to the natural log of 17, and then to move the power in front. So then x natural log of 13 equals the natural log of 17, and then you divide, right? Or in general, you solve for x. X equals natural log of 17 over the natural log of 13. That's what they want here, and then you'll just put this in your calculator, natural log of 17 over the natural log of 13, and in the TI it goes ln 17 close parentheses / ln 13, and then you simply round that to 2 decimal places. Number 4, we're talking about 7e. Number 4, talking about 7e. I believe it's to the 4x, 7x equals 2471. I just want to double check that that's right. 2471. Right, so then we'll divide, we're solving for this x here, right? So we're going to divide the 7 out. Hopefully that goes evenly. E to the 7x equals 2471 divided by 7 is 353. 353. And now we're back to what we've said before. Now we have an exponential function. We're trying to solve for this. We take the log on both sides. The natural log of e to the 7x equals the natural log of 353. This is nice because the natural log and the e, they cancel. So 7x equals ln of 353. Mx equals, you can write all sorts of things, right? So you can do ln 353 all over 7. And again, I think that they'll ask for that. ln 353 over 7. And then again, you'll round to a couple decimal places. It's important, again, that when you put this in your TI calculator, you close the parentheses and divide by 7. Five, the bases are not equal, and so you've got some work to do here. 7 to the 5x plus 3 equals 2 to the x minus 4. Same deal, let's get it. Natural log of 7 to the 5x plus 3 equals the natural log of 2 to the x minus 4. We're bringing all powers in front, and we're obsessed with solving for x. Bringing powers in front. We're talking about 5x plus 3 times, all times the natural log of 7 plus, equals x minus 4, the natural log of 2. Answer is going to look nice and ugly. It's not going to be our typical answer, but it will be an answer nonetheless. We just have to be careful how we put it in the calculator. Well, again, we're solving for x, so we need to distribute. So it's 5x natural log of 7 plus 3 natural log of 7 equals x natural log of 2 minus 4 natural log of 2. And again, it's these two x's we're solving for. I should highlight them here. It's this x, and they need to get on the same side. So 5x natural log of 7, I'm going to put them on the left-hand side. That's my choice. You can put them on the right-hand side. Equals minus 3 ln 7 minus 4 ln 2. So we're just moving stuff around. If I want to move this x natural log of 7 to the left, I need to subtract it. If I want to move this 3 natural log of 7 to the right, I need to subtract it because it's positive, right? So that now we can factor out an x, right? So it goes x times 5 natural log of 7 minus natural log of 2 equals minus 3 natural log of 7 minus 4 natural log of 2, and then we go ahead and divide. Right, so then x is the super ugly minus 3 natural log of 7 minus 4 natural log of 2 all over 5 natural log of 7 minus the natural log of 2. And when we start thinking about how to enter that into the calculator, we're talking about parentheses minus 3 ln 7 minus 4 ln 2 close parentheses slash parentheses 5 ln 7 minus ln 2. That's how we put it in literally in the TI calculator. And then you probably need to round that to 2 decimal places. Number 6, we're being a little tricky. We have multiple exponentials here. As a matter of fact, we have a quadratic as an exponential. We have a quadratic in the exponential. What does that mean? Right? It means that if you took a look at at this in terms of e to the x, then it looks like something that we can factor. So the first thing we'll do is we'll make a substitution. Right, and so we'll say let u be e to the x, and one of the reasons why we're doing this is because if we do that, then we might be able to see that this is really just a quadratic equation. So when you look at if u is e to the x, then when you square both sides, then you're squaring e to the x, but again we multiply this x and the 2, and so this is e to the 2x. And so making this substitution, then we get that u squared minus 14u plus 13 is equal to 0. And then we'll immediately see, oh, this is a quadratic that I can factor. Right, so this is one of the tricky ones. Factors of 13 that add up to 14, negative 13 minus 1, u equals 13, or u is equal to 1. And then at this point, we have what u is, but it wasn't really u that we were solving for, it was x. And so if we replace e to the x back in here, you get that e to the x is equal to 13, or e to the x is equal to 1. This one automatically is 0 because our number to the 0 power is 1. And here we'll go ahead and do our natural log business, right? So this is the natural log of 13, x is the natural log of 13. So it's a natural log of 13, or x is 0. So you're putting in 0, ln 13 into the solution set. Let's see if they're asking for you to round. Looks like they are, okay, to 2 decimal places still. So we just finished solving exponential equations. Now we're going to solve logarithmic equations. There are going to be a couple ways to solve those. One is just simply by the definition. Let's remember the definition that when we write y equals log base b of x, then by definition it means that b to the y power is equal to x, right? And so in this case we have log, I think I can put it here, I have log base 3 of x plus 4 is equal to 2. I'm solving for x. We're going to switch this to exponential form, which allows us to get x by itself. 3 to the second power equals x plus 4. 3 to the second power equals x plus 4. X is 5. 3 squared is 9. 9 is equal to x plus 4. Subtract 4 on both sides. X is 5. Same thing here. X 2 to the second power equals x plus 13. 2 to the second equals x plus 13. X is equal to, so well, let's write this. 4 is equal to x plus 13. X is equal to negative 9, subtracting 13 on both sides. That's perfectly okay. Answer's going to look semi-ugly. That's perfectly okay. I've got 8 natural log of 4x equals 40. You want to get x by itself. We got this 8 here. We're currently multiplying by the 8 to get rid of it. We need to divide both sides by 8. You have the natural log of 4x is equal to 5. You just remember that the base here is e. Using that definition, e to the 5th is equal to 4x. Again, e is just a number like anything else. We'll treat it that way. E to the 5th is 4x. We're solving for x. We're multiplying by 4. We need to get rid of the 4. The way we do that is to divide. E to the 5th over 4 is the nice ugly answer. 5th over 4. Here they're going to have you round to 2 decimal places once you put that in the calculator. Again, it's going to be e to the 5th like this, in parentheses, divided by 4. There we were solving logarithmic equations using the definition. Here we're going to use some log rules. Recall that the last rules that we talked about in class were log base b of a plus log base b of b is equal to log base b of a times b. So that addition turns into multiplication. The game plan for these is to turn both of these logs into one log and then do exactly what we did before. Okay. So we have, let's take this. This becomes one log. This is equal to just the left-hand side, leaving the right-hand side alone. Log base 4 of x times 3x minus 1 is equal to 1. Here we can then apply the definition that 4 to the first power equals x times 3x minus 1. 4 to the first equals x times 3x minus 1, and now we're about to build a quadratic equation. I'll switch the orders. X times 3x minus 1 is equal to 4. 3x squared distributing the x. 3x squared minus x is equal to 4. And so now we've got 3x squared minus x minus 4 is equal to 0, subtracting 4 on both sides. Got a factor 3x, x. We got to get a minus 1 in the middle. Minus 4 plus 1. You can check that out to see that that foils pretty nicely. This means that 3x minus 4 is equal to 0, or it means that x is equal to negative 1. So solving for x, 3x is equal to 4, x is equal to 4 over 3, or x is equal to negative 1. And now we'll put this in green, that this is a place where we need to check. And the reason is because that when we brought these together, this introduces an incorrect answer. And it's this negative 1 because there's no way we could take that negative 1 and put it here for a log, right? The answer is 4 over 3 and 4 over 3 alone. And this one's 4 over 3. 11 references one of the other rules we talked about, and it is the division rule, that when you have ln or the log base b of a minus log base b of b, this is equal to log base b of a over b. So using that rule, this subtraction turns into division. It's log base 6 of x plus 32 over x minus 3 equals 2. And now we're solving for x. We can now invoke the definition. 6 to the second power equals this fraction. 6 to the second power equals x plus 32 over x minus 3. We'll raise 6 to the second power, and then we'll cross multiply. 36 is equal to x plus 32 over x minus 3. We'll cross multiply. 36 times x minus 3, 36 over 1, equals x plus 32. We'll get a fraction. We're going to check to see whether this fraction is going to be nice or not. We'll distribute the 36. Looks like we got a 35 equals 135x equals 140x is a very nice 4. Plugging that 4 in looks like you get something that's okay, something that's okay. It looks like it checks out. 4. As you divide both sides by 35. 4. Here we're still going to continue to use log rules, and then at the end we're going to do something that was analogous to what we did for exponential functions. We're going to use this subtraction, turn it into division, and then we're going to have logs on both sides. This is log of x plus 7 over 2 is now equal to, I'm not going to do anything to the right hand side. I'm going to leave it alone. Leave it alone. Now, when we had the same bases, we drop the bases and make the powers equal. Here we have logs on both sides that you can just go ahead and just drop the logs. Right, so when logs are equal, you can drop the logs. We're making that there. Okay, so logs are equal. Drop the logs. Here we're going to multiply both sides by 2. X plus 7 equals 8x plus 2. Looks like we've got a 7x equals 5. X is a funky 5 over 7. $13 looks like it's the same thing, except now we're going to be multiplying. We're going to use some log rules to bring one log on both sides, and then we'll drop the logs and we'll be left with a quadratic, and we hope that at least one of the answers is going to be a solution after we check. Addition turns into multiplication. This is the natural log of x minus 6 times x plus 1. And that equals the natural log of x minus 15. We'll drop the logs. You get x minus 6 times x plus 1 equals x minus 15. We'll go ahead and FOIL the left-hand side. Alright, so we'll just do x times x times 1, minus 6 times x, minus 6 times 1. FOIL that out. And then we'll bring everything to one side. X squared minus 6x minus 21. Sorry, looks like it's plus 9. We'll add 15 to both sides. Add 15 to both sides. Let's just write that. It's like a very nice 9. And that equals 0. That factors x minus 3 times x minus 3 is equal to 0. It looks like x is 3. And going back up, 3 does not work, right? The natural log of 3 minus 6 is the natural log of negative 3. So that does not work. 3 is not a solution. Does not check. The only thing that we got as a possible solution doesn't check. There is no solution to this one. Let me just click no solution. Doing some word problems. Here, when we're trying to figure out which letters which, we got a lot of letters going on. We got T and we got A. So sometimes we'll give you A and we'll solve for T. Sometimes we'll give you T and we want you to figure out what A is, right? So you just have to read it carefully. The formula A equals 15.7 e to the 0.0403 t models the population. So this is the population. T years is time after 2000. What was the population of the state in 2000? That's in the beginning. That's always just that number, 15.7 million. You can also get it by plugging in 0 for T. That makes this whole thing 1 and you get the same thing. The population of the state will reach 18.7 in the year. So that means that it means you want A to be 18.7, and then you go ahead and you solve that, right? So then you've got, and I guess I'm gonna get Desmos out here, so let me do that as I'm gonna start using the calculator. So then 18.7 equals 15.7 e to the 0.0403t. What I would just like to let you know is that this, even though it may look ugly, we're not going to do anything differently than what we've been doing before. We're going to go ahead and solve for t. We're going to divide both sides by 15.7 because we're currently multiplying by it, right? So when you do that, we got e to the 0.0403t is equal to 18.7 over 15.7. And we'll go ahead and we'll apply the natural log to both sides. The natural log of e to the 0.0403t equals the natural log of 18.7 over 15.7. And then the natural log and e cancel. We now have 0.0403t is now by itself, and it equals the natural log of 18.7 over 15.7. And now we're solving for this t, and this needs to be divided out. It's 0.043 is now going to divide both sides. And this will happen a lot, right, in these type of log problems where the answer looks this ugly. And now we need to round, and this is why we'll bring Desmos in here to do this carefully. I'll make that smaller. It's ln, we'll get the fraction out first. It's ln 18.7 divided by 15.7, arrow close, and the denominator is 0.0403. And then I need to be rounding. It asks to round to the nearest year. So then the other remark is that this is in the nearest year, so it's 4, but they want to know it's t years after 2000. So here, this is approximately 4. The answer is the year 2004, 4 years after 2000. So that's in the full context of the problem. Okay, 15 more word problems. The function f of x equals 20 times 0.955 to the x minus the percentage of sunlight f of x that reaches a depth of x feet. So x is in feet, we're just looking at the units, and f of x is in a percentage, right? Use the function to determine at what depth, that means they're looking for x, at what x to the nearest foot, you're going to round to the nearest whole number, there is 1% of daylight. How is this shown on the graph, right? So that means you're going to set 20 times 0.955 to the x equal to 1. Okay. We're going to go ahead and divide both sides by 20. So 0.955x is equal to 1 over 20. And we're headed right to natural log town. The natural log of 0.955 to the x is equal to the natural log of 1 over 20. We'll bring the x in front. X natural log of 0.955 equals the natural log of 1 over 20. And then we'll divide. X is equal to the natural log of 1 over 20 over the natural log of 0.955. ln 1 over 20 so 65.06. Let's see what the units are. And that looks about right. 1%, 65, right? So that's approximately 65. Right. What point on the graph does this represent? The x coordinate was 1, the y coordinate was 65. This is the question I kept talking about with my wife in terms of how much time is this $11,000 going to become $20,000. We're going to solve for t there. I'll do this one and save 17 for you to do. Again, this one's going to look semi-ugly. We're going to do it just like everything else. In this case, this is P, N is 2. The interest rate we need to write as a decimal is 0.0625. The amount at the end needs to be A, and it's T that we are looking for. Filling that stuff into the formula, it's 20,000 equals 11,000 times 1 plus 0.0625 over 2 raised to the 2 times the number times the number of years, which is what we're looking for. Again, we're solving for t. This 11,000 is currently multiplying. I need to get rid of it. To get rid of it, I need to do the opposite of multiply, and that is divide. We'll divide both sides by 11,000. That gets us all the thousands cancel. It's 20 over 11 equals, and then what I want to do is I just want to get a nice decimal if I can for this. 1 plus, actually let me just use decimals. It's 1 plus 0.0625 divided by 2. And they've got 1.03125. 1.03125. I do want to double check that. 1.03125. Okay. All right, and now we're at log town. So the natural log of 20 over 11 equals the natural log of 1.03125 to the 2t power, and then we'll bring the power in front using the power rule. The natural log of 20 over 11 equals, bring the 2t in front, natural log of 1.03125, and then what we want to do is we want to divide by all of this stuff that is not the thing we're looking for, right? So then we're going to divide 2 natural log of 1.03125 on both sides, and then that is the super ugly number, right? So the time it takes is t equals ln 20 over 11 all over 2 natural log of 1.03125, and that's Desmos all day, right? So then yeah, you can just put that in. Um, 17 is nearly the exact same problem. They want double the amount invested. You invested 8,000, so they just want 16,000. And you solve for t the same way we did 16. They give us a function that represents this data, f of x equal to 1.5 ln x plus 14.6. And now they're saying that the given bar graph shows the percentage of gross domestic product, GDP, in a state going toward healthcare from 2007 through 2010 with projections for 2014 and 2019. The data are modeled by the function f of x equals that, where f of x is the percentage. This is a percent. of the gross domestic product going toward healthcare X years, this is in years, after 2006. Use this information to solve parts A and B. Use the function to determine the percentage of gross domestic product that went towards healthcare in 2008. 2008 is 2 years after 2006. And then that just means that you need to look at the function at 2 years after 2006. So you're just plugging in 1.5 natural log of 2 plus 14.6, and you're calculating what that is. In 2008, you're comparing that to 15.1. So whatever, let's just see if we can get what that is. So 1.5, the natural log of 2. 1.5 ln, we'll put 2 here, and then plus 14.6. It's going to be close, actually, plus 14.6. It's 15.6, and let me just make sure that's 14.6, right? 14.6. It is, and 15.6 is what we get to 1 decimal place. That's 15.6%. That's our estimate using our function. The real answer is 15.1, and so we have too much by 0.5%. According to the model, when will 18.4% go towards healthcare? They want the percentage to be 18.4, so they want the function to be 18.4, and now we're just going to solve this thing. Right, so that we're going to solve for x here. Trying to get x by itself. I need to get rid of this 14.6. I'm currently adding it, so I need to subtract it on both sides. 14.6. 18.4 minus 14.6 is 3.8. That equals 1.5, the natural log of x, and then we're solving for x. I'm currently multiplying by 1.5. I need to get rid of it, so I'm going to divide on both sides, 1.5. So then I've got the natural log of x equals 3.5 over 3.8 over 1.5, and then we'll use the definition. The base is e to the 3.8 over 1.5 is equal to x. X equals e to the 3.8 over 1.5. Round to the nearest year, x is in years, e to the 3.8 over 1.5. E to the 3.8 over 1.5. 12.6 years. They want us to round to the nearest whole number, I believe. So we're talking about 13. So this is roughly 13. And so the year, it's after 13 years after 2006. It's 2019. And so then let's see if that actually fits the data. 18.4%, right? And in 2019 it was 18.9. So it looks like in that year is probably when it happened, sometime earlier in the year. All right, I hope it helps. Oh, wait, no, there's more. Maybe that's the last one. Yeah, that is the last one. Okay. So then we got 19, which asks a very similar question. P of x is equal to 90 minus log base 2 of x. Let's see what this means. This is also, again, a percentage of students who could recall the important features of a classroom lecture as a function of time, where x represents the number of days that have elapsed since the lecture was given. This is days. This is actually for us because we only meet once a week. Right? This problem applies to us. After how many days do only 3/4 of the students recall the important features? So 3/4 is 75%. So they're saying 75% and you're solving here, log base 2 of x, right? We'll subtract 90 on both sides. Minus 15 equals minus log base 2 of x. We'll drop the minuses on both sides. This number looks huge, so it's 2 to the 15th is equal to x. Round to 1 decimal place as needed. I'm trying to see. This models the percentage of students who could recall the features of the classroom as a function. Right, so this makes sense. It just takes a long time, 2 to the 15th days. I don't think we'll need to just put that in your calculator, and that's the number of days. It takes a long time for that to get to 75, because log base 2, wait, no, we have, that's not fitting this is at all. Wait, what has happened here? Minus 15. Oh, there's a 30 here. That 30 would be helpful. All right, great. So then it's minus 15 equals negative 30 log base 2 of x. Right, then you divide both sides by negative 30. So the negative, I'm sorry, that's positive 1/2 equals log base 2 of x, and then you raise 2 to both, then you use the definition, 2 to the 1/2 power equals x. X is equal to 2 to the 1/2. That is the square root of 2. Right. Round to 1 decimal places, that's 1.4. Square root of 2, square root of 2, 1.4. And then that looks about right according to the picture. Right, 1.4, that you get about 75. There's 70, 75, 1.4. Order pair 1.4, 75. Okay. Hope it helps.